All right, this is going to be a video from section 3.5 where we're introducing to you rational functions. A rational function is basically a function that's in the form of a fraction, where I have a polynomial on the top and a polynomial on the bottom. And you remember that you're not allowed to have 0 on bottom, so the polynomial on bottom, q of x, is not allowed to be 0. I'm going to introduce you to two new parents in this first video in this section. So the first parent is going to be the reciprocal function. Remember that with all of these parents, you should be memorizing three things. First thing that you memorize is the name of the parent, so that's going to be the reciprocal function. Secondly is the equation of the parent, so this one's going to be f of x is equal to 1 over x. And thirdly, you're going to memorize the graph of the parent with some special points. So let's take a look at that graph here. And notice the first thing is that you cannot have 0 on bottom. So whenever my x value is 0, then my whole entire function is going to be undefined. And so what we're going to do is we're going to draw a vertical asymptote through x equals 0, through the line x equals 0. This is kind of like a no man's land. Your graph is not allowed to touch this vertical asymptote, but it's always going to get closer and closer and closer to the vertical asymptote. Now, if you cannot have an x value of 0, the other question that I would ask is, what x value could you plug in to get out a y value of 0? Well, the answer to that is there is no x value that you could plug in and come out with a y value of 0. So then we also have a horizontal asymptote going through y equals 0. So digitally, you don't necessarily see those asymptotes show up, but whenever you draw on paper, which you will be asked to do for the test, you are required to draw those asymptotes. Now, I want to look at two special points, and the first one is going to be 1, 1, where we're going to move right 1 and up 1. And the second one is going to be -1, -1, where we move left 1 and down 1. And this is going to help us when we are drawing transformations of this parent. So quickly, we'll move through these questions. My domain, I can just use the graph here, is going to be all real numbers except for 0. My range, also all real numbers except for 0. My whole graph is decreasing, but since I'm not allowed to equal the value of 0, we have to break that up into two intervals. My graph is discontinuous at x equals 0. And last but not least, the x-axis is a vertical asymptote and the y-axis is a horizontal asymptote. All right, so then what I want you to do is go ahead and skip down to the next parent. And so the next parent, your textbook calls the next parent the rational function. I call this parent the reciprocal square function, because it looks exactly like the reciprocal function, except for the fact that the bottom, the denominator, is squared. And so that's the name that I use. The textbook uses the name rational function. You need to be familiar with both of those. My equation, as you can tell here, is f of x is equal to 1 over x squared. So once again, as we go to the graph, we can see that x is not allowed to equal 0. So I have an undefined place when x is equal to 0, so we're going to draw our vertical asymptote there. And just like on the last parent, there is no value of x that you could ever plug in that would give out a y value of 0, so we also have a horizontal asymptote through y equals 0. And then two coordinates that are important is they're going to be moving to the right 1 and up 1 and to the left 1 and up 1. Both of those are going to be important coordinates when we start transforming the graph. All right, so the domain, once again, is going to be all real numbers except for 0. However, the range is going to start at 0 and work its way up. My graph is going to increase from -infinity to 0 and then turn around and start decreasing from 0 to infinity. It's discontinuous at x equals 0, and then once again the x-axis is a vertical asymptote, the y-axis is a horizontal asymptote.